Hi, welcome back. We're on question 4 of the 2012 November examination, Higher Level Namibian Syllabus, Paper 2. Okay, so let's get into question 4. We are told in question A to express this as a single fraction. So let me just rewrite the question so we can see exactly what's going on there. So that's a over x plus 2 minus b over x minus 3. Okay, so we've got two fractions. What do we do if we want to add or subtract fractions? Well, we have to get a common denominator. So let's start with this denominator here, which is x plus 2. And then we check, okay, what does this one have? Well, it's got an x minus 3, which is not there yet, so we're going to use that as well. Okay, here we had an a. Now this fraction still had to be multiplied with x minus 3. And then here we had a b. This fraction still had to be multiplied with x plus 2. Okay, and let's multiply out. So this gives us ax minus 3a. This gives us minus bx minus 2b. And the denominator stays the same. We don't want to multiply that out. That's also a general good tip in general. Don't multiply out your denominators. Leave them as factorized as possible. Okay, then this would be fine as a final answer. You don't have like terms that we can really add, but we can in some sense add them, at least these two, right? They're sort of like terms, so we can factor out an x. So this should be fine for full marks, but I'm just going to go ahead and factor out an x here. So that'll give us a minus b x, and then minus 3a minus 2b should be fine just like they are. And we're going to keep the denominator still not multiplied out. Alright, so that is our final answer for question A. And like I said, this should be fine as well. That's fine. Question B. Hence, find the values of A and B if... Okay, so we have our original equation. I'm just going to copy this and paste it here. So we have that equal to or equivalent to, actually 3 lines, to negative 2x minus 9 over x plus 2, x plus 3. X minus 3, my bad. X minus 3. Alright, so now what we see, we already know what this answer is, right? This answer is this part. So we're going to copy that, paste it here, and change it to red. Okay, so we know that's equivalent to the... Let me copy again. This is too easy. This is so nice. And, oops. Okay, so one of them can go there. No, let me undo that. Sorry for the delay. Copy and paste. There we are. Alright. Now, we want to use equivalence just like we did in the previous question. Go have a look at the previous video if you want to check how we did equivalence, but we're going to do it again anyway. We see the denominators are exactly the same, so we can, in essence, cancel them out, or say multiply both sides by this in it, but whatever we do, this will go away. So now we just have the top part equals the top part. And we see there's a x with a coefficient on both sides, and then there's a constant on both sides. So those things must be equal. So let's start with the x to the power 1s. Coefficients of the x's must be equal. So on this side, that coefficient is a minus b. A minus b. And on this side, the coefficient is negative 2, so it must be equal to negative 2. Now we've got the x to the power 0s, or the constants. On the left hand side we've got negative 3a minus 2b, and on the right hand side we've got negative 9. Good, so we've got two unknowns, we've got two equations, so we can solve the equations. Okay, so I want to do elimination here. So the coefficients of the a's or the b's must be the same. So at the moment they're not. So I'm just going to say let's multiply this whole equation by 2 and write that down at the bottom. So a times 2 is 2a, negative b times 2 is negative 2b, and negative 2 times 2 is negative 4. So the b's have exactly the same coefficients, so we can subtract the two equations from each other. We get negative 3a minus 2a is negative 5a. Now negative 2b minus negative 2b is nothing. And then negative 9 minus minus 4 is negative 9 plus 4, which gives us negative 5. And then divide both sides by negative 5, and that gives us a equals 1. Great start. So let me just do this. And now we can substitute this a equals 1 into any one of these equations. I'm going to use this one. So a minus b equals negative 2. So a we know is 1 minus b equals negative 2. And then we just solve for b. So I'm going to keep the 1 this side, bring the 2 over, and then take the b over to the other side. So we have 3 equals b. And that is done. That's it. A is 1, b is 3. And the nice thing about mathematics, you can almost always go check your answers. So you can plug these values in and just make sure everything works and everything is fine. Okay, great. So that is it for this video. And then I'll see you again shortly for question 5.